Hey, this is Mark, and today I've got a Samsung S8 that has come in for data recovery. And the note says S8 woke up one morning as a brick, wouldn't boot, looking to get photos and videos, etc. Um, so, uh, before I jump into troubleshooting this in the way that I normally would approach one of these, I want to take a minute just to talk about um, what what the schematics that are out there for this can tell us. So we need to get schematics up here. Ah, I've been a little more prepared. Bear with me. All right. Let's see if I. All right. So should be two schematics now. All right. So here's what's available for the S8 schematics. We've got like a picture of the board here with a bunch of chips and connectors and stuff labeled. So, limited usefulness. I mean, I guess it's useful to know that if you have a problem with the barometer, that's the chip for it. Or oh, here's your Wi-Fi chip. But not a lot we can learn from that or is useful. Um, oh, look here, there's the CPU. And oh, memory's under this shield. Okay, thanks, schematic. And then we have kind of a really high level block diagram that's basically saying all of these things talk to the CPU. Again, not super useful, but maybe we could learn something from that if we needed to troubleshoot. Then we have like a board layout that has labels for all the components, which would be useful, if you're like trying to tell somebody else how to fix something you've fixed. You'd have a frame of reference with the names of things, but it doesn't actually give you a list of the parts. Um, Actually, it might give you a list of parts at the end. Nope. Sometimes they'll give you a list of parts at the end, but it doesn't have values. So really limited usefulness there too. And then we keep going down and we get to the troubleshooting section. Um, Now this phone is not powering on, so we'll follow the flow chart. We'll say mobile phone does not power on. Um, and is the battery voltage more than 3.8? In my case, the battery is not. So I'm going to now get a charged battery, and then we will no longer be in a state of no power, which I'll show you in a minute. But just for the sake of discussion, let's say that this is a different case than what I have, and let's say I'm working with a phone that's short on main. So, even with a charged battery at 3.8, we're still going to stay in no power. So if that were the case, if we had a short on main, then we would say, yes, the battery voltage is 3.8. And then the next thing the thing would want us to do is check and see, do we get a power on sound, and does the vibrator motor vibrate? And if we had a short on main, the answer would be no. If the answer was yes, it'd say, okay, change the LCD display. You've got a bad screen. So saying no, we would check the voltage on R304 while pressing the power key, basically saying, is there voltage coming to the power key? And or through the power key after you press it. If the answer was no, it would want us to replace the power button. If the answer is yes, which it undoubtedly would be in our made-up case of main short. Then it would say check the signal that is running to the power key. And if that was not present, If that 1.8 wasn't running out to the power button, then we would check all the outputs of the main PMIC, and if it's not normal, change the main PMIC. But let's say that voltage would be present, yes, then it wants us to check the clock and see, is the clock frequency correct? And it would be, because our problem's a main short. So then if that was the case, it would want us to move on to the initial operation, which is here. And it would say, initial failure, yes, re-download software on mobile phone. We can't do that because we have a main short, so not possible. Recheck our power on troubleshooting process. Yeah, not possible. And then it would tell us to change CPU and then change the logic board. And that's just wanted to point out that the schematics that are available for these Samsungs come with these troubleshooting flowcharts, which maybe for an area down here where you're troubleshooting cameras, that would be useful. But when you're dealing with a no power device, really, it's just going to waste a ton of your time. So let's go back up and say, we're going back to the case we have now. So I will pull that back up. All right, so now we're back to our S8 that's in question here. And if I hook up a good battery, and I try to power on, what I'm getting is the vibration, the image, but then it's gonna boot loop. Yeah, see now this is normally when we would get the animated Samsung logo, but instead this one is going to boot loop. So, so we've got some kind of unknown problem that is outside of what our troubleshooting flowchart from Samsung can help us with. So what should we do? Well, one thing we can check just to gather information is we can see what kind of charging current does it pull. So I am going to swap out my DCPS cables for a USB Type-C charging cable. And that way we can look at what kind of current is being pulled. Oh, I need to get that app open. There we go. So we need to set our voltage back up to 5 volts. And we are pulling a charging current, but it's very, very low. And we aren't getting the symbol on the screen, that would show us that this phone is charging. So we're pulling about 700 milliamps, not even 1 amp, when really this should be charging at over 2 amps. So, we're not pulling correct charging current, and the phone does appear to be attempting to boot, but then it just stops and boot loops part of the way through. So what else can we do to gather information? Now I notice when I pull this board out that the bottom end of it feels kind of warm. So I'm going to see if I can find a dock. And let's just hook up a battery and a dock. Let's see what's getting warm down here. Oh yeah, I can definitely feel something down there at the bottom of the board getting warm. Something in this area definitely getting warm. So let's see. All right. Looks like this guy right here definitely getting hot. Okay, so we are getting somewhere. So we've got this guy's getting hot. So I don't know, what should we do? What if we check and see if there's any lines around there that are short to ground? All right. Oh, what luck. That looks like that might be short to ground. Let's get this dock disconnected. All right, this line seems like it might be short to ground. All right, so it looks like this guy and this guy both maybe are on lines that are short to ground. Now I'm going to grab my test board. I like to take measurements against this board sometimes. Sometimes I grab components off of this board. So let's see. All right, we were getting 0.065 on this line on our problem board, and on this one we're getting 0.440. And we were getting 0.065 over here. Now we're getting 0.453. So we definitely found two lines that appear to be short. So let's see what our ZXW can tell us. Oh, no, that's not right. Let's see. Give me 1 second. I should have set this scene up before. There we go. All right. Bear with me. Okay, so we got ZXW open, and let's see. It's not really going to tell us the names of lines. You can say, all right, this guy, this little cap is on a line that connects to a bunch of pins on our dock. I'm going to say that's probably like the main 5-volt charging voltage coming in. And then this guy is on some other line that connects that same chip to this little chip down here. And see, this little chip is connected to, looks like a coil, some sort of an enable. So not convinced that this is the line that's shorted. It may just be that this line is causing this line to also be pulled down. So I would say my first candidate for a problem here is going to be this chip itself. So yeah, I think probably this guy, this M005X02, he, I bet, is going to be our culprit. So let's yank him off. See what happens. All right. So now, no longer short. So seems like that was our guy. All right. So since we suspect that that chip is bad, we're not going to do anything with that chip. We're going to leave it off. In fact, we're going to toss it in our junk pile. And we will steal this good chip from my good donor board. Now we are going to have to reball this, so we'll get the bottom of the chip cleaned up, and then we'll have to find a stencil that is going to work for it. I do have some S8 stencils, but I don't really like the quality of them as much as I like my iPhone stencils. So what I prefer to do is to just find an iPhone stencil that fits. Doesn't have to be exact. It just has to have the right spacing and size of the balls. That's not going to work. Looks like that guy's going to work. And there we go. Now, I think I remember it being just like that. Our orientation mark was in the top left. I believe it was. I hope. Okay, so one thing I could check real quick is to see, are any of these balls connected to each other on the bottom of the chip? Oh, got to change the battery. All right, we'll check this first and then we'll change out that battery. So sometimes you can see like really clearly on the bottom of the chip where, you know, two balls are connected to each other, and then you can match that up on the board. But no, I don't really see anywhere that two balls are clearly connected. Maybe these two? Those two might be ground. Let's see. Let's see if they talk to each other. Multimeter says no. Nope. All right, no such luck. We're just going to hope that my memory serves me correctly. Or else I'll have to stop recording, rewind, go check the video. Oh, let me just double check and make sure I don't have another matching board. Now, it's like these other boards that I have are not the same. Is this guy close? Not really. I feel pretty good about it. I'm sure it'll be fine. All right, let's stick this sucker back on here and see if it works. So let's check and make sure that our short is still gone. Or shorts. Yep, those seem fine. All right. Moment of truth now. Let's see, are we going to charge at the correct? Not really. All right. Well, it could be that my battery's already fully charged. Let's see what it does in its own housing again. I've already checked the voltage on this battery and it is 0 volts. So I'm not even going to try with the battery that's in it. I just want to try out with my good battery and see, do we boot now? All right, well, we are definitely in better shape than we were before. We've got that Samsung logo. Oh, and you know, it just occurred to me that Samsungs do not like to charge properly if you don't have the wireless charging connected up. So that is probably where our issue came from. So we are fully booted up now with our charged battery, and let's see if our dead battery is going to start charging. So I'm just going to connect all these little guys up, and I'm going to get the wireless charging little piece here. I'm just going to pop that on. Oh man, you fool, Mark. I just realized that this whole time I've been acting like you can see what I'm talking about through the camera that has died. All right, bear with me, people. Okay, let's get that back into focus. All right, so pop this back up and we'll show again with my charged battery that we are booting up. So now we're getting that second Samsung logo, the animated one that we like to see. And there we go. We're booted up and the phone is on. So we're good to go there. So now we're going to hook our original dead battery back up, plug the wireless charging in, and then let's see. Okay, it's probably going to take a while. From a 0-volt battery, probably take a while. I was kind of hopeful that it would at least show us the image on screen, but like an iPhone, the Samsung does not. It needs a certain amount of power on the battery before it's going to show you anything on the screen. It won't show any display at all if you've got a stone dead battery that has not started charging even a little. And it may be that this battery just won't take a charge because it's too depleted and needs to be replaced. But at any rate, I can get data from this. And if I had relied on the troubleshooting flowchart in the Samsung schematics, I would have just wasted a ton of time taking measurements that would not get me anywhere. So the point of that is when it comes to Samsungs, don't trust their level 3 troubleshooting guides. Just use your brain, take measurements and think about how did it come to be like this, and you'll save a lot of time. All right, so that is that. Another one done. Thanks for watching.